welcome to a new set of video notes. We've moved on to Chapter 3. You have hopefully done a great job in Chapter 1 and 2, and now we're on to 3. 3 is a lot about systems of linear equations, and where that sounds scary, it's really not all that frightful. So, got the title, 3.1, Solve Linear Systems by Graphing. Well, we probably need to figure out what a system is, or a linear system. So I thought we'd talk about that. System of linear equations. Usually that's two equations, both represented with x's and y's. With y's and x's. And a lot of times we'll have it in that slope-intercept form that we worked so hard on last chapter. Okay? Now, today we're going to look at graphing it. So the steps are pretty easy. The first step is graph first equation. Your second step is graph your second equation. And then your third step is to look at the graph. Okay? Not too terribly difficult. What might happen between these two different lines? Well, one thing that can happen is that they cross. We call this point the solution because it's the one point that works in both equations. It's one solution, and we can classify that as consistent because it has at least one solution, and independent because it has exactly one. Okay? Another thing is that the lines can wind up being right on top of each other, or called coinciding. You might remember that in geometry we talked about coinciding lines. They have infinitely many solutions. Any one of these points along here will work. So we say it's got at least one solution, it's consistent, but it has so many different ones, we call it dependent. The last thing that can happen, the lines can cross, the lines can lay on top of each other. What's the other thing? Oh, that's right, they never cross. So here's that example. These are two parallel lines, and it's no solution because we know parallel lines never cross. If there's no solutions, we call it inconsistent. Okay? What I want to do now is kind of do a practice problem. We're going to do some work over here on this board, and then we're going to look at the solution. But remember, we'll turn out lights because that's hard for you all to see. So, I'm going to give you a system of equations. I've got two of them. 4x plus y equals 8, and I've got 2x minus 3y equals 18. Okay? Well, if you recall, what's our first step? Oh yeah, we need to graph it. So, there's a couple different ways you could graph this. I think for today, we'll just look at getting it in slope-intercept form. So we've got 4x plus y equals 8. Huh? You thought you were done with notes? You're not. I'm just going to keep talking while they keep ringing that blessed bell. The y is not by itself. We need to get it by itself, which means we need to get rid of the 4x. How are we going to get rid of it? Oh yes, we're going to subtract. If we subtract, we're left with y. Can we combine these? Oh no, because this is a plain number and this has an x in it. So you would not call these like terms, and you're right there. So when we go to graph this, we want to go up to 8, and then our slope tells us go down 4 and over 1. Okay? Let's look at this one. This one's going to be a little bit more involved to get it in slope-intercept form. So, let's rewrite it. 2x minus 3y equals 18. So you subtract 2x from each side. Now, you're left with negative 3y. Can you combine these? Oh no. Negative 2x plus 18. We've got the y almost by itself, but what's still there? A negative 3. How are we going to get rid of that? Okay, divide. So, getting a little more involved. Negative divided by negative is positive. Can't really do anything with the 2 and the 3. Here's a good question. What's positive 18 divided by negative 3? Well, it's negative 6. Okay? Now, what I want to do is show you on the slide what this looks like, okay? So we'll go ahead, we'll turn off the lights and look at this particular slide. It says graph the linear system, and then we're going to estimate the solution. We can also check it with algebra. So here's your two equations. Now the textbook doesn't make a big deal about graphing the lines, but I still think we need to review that. So let's look over here. Let's see. This is the line 2x minus 3y equals 18. Notice 1, 2, 3, 4, 5, 6. It's going through negative 6. The slope is 2/3. So you go up 2 and over 3. And that gives us this line. Okay? Now the other line, way up here off the screen where you can't see it, it crossed at 8. And so then we go down 4 and over 1, down 4 and over 1, and then we get here. Okay? Notice these two lines intersect exactly at the point 3, negative 4. Okay? So what your book talks about is checking this algebraically. Now, you could just plug into your original, or you could use the one that we did. Doesn't really matter. But we're going to go ahead and put in the 3 for the x and the negative 4 for the y. So 12 plus a negative 4.
Alita CR to the main office. Alita CR to the main office.
Isn't this nice that even though you're not at school, it feels like you're at school because of that? So is 12 minus 4 equal to 8? It is. It's a true statement. So we know this point, 3, negative 4, is actually on that line. And I'm going to remind you. So 3, negative 4 is on the line. Let's see if it's true for the other one. If we put in 3 for x and negative 4 for y, we get 2 times 3, which is 6. Negative 3 times negative 4 gives us 12. 6 plus 12, does it equal 18? It does, so that's our solution, okay? And that's what we're really going to do. Now I want to point out, and we're going to work backwards so I can point this out. Remember how we looked at graphing from the y-intercept and the x-intercept, how you could put 0 into both of these, and you'd get y equals 8. And if you put 0 here, you get x equals 2, which is where it's crossing. If you put 0 in for x, I think when you solve, you get y equals negative 6. And if you put in 0 for y, you get x equals 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, you get to 9. So either way, you're still going to get the same graph. And in a little bit, we're going to look at how to do it on the graphing calculator. In fact, let's do that right now. So I'm going to get out of this slideshow, and you'll get to watch this end the show. And then I'm going to pull up the graphing calculator, and we're going to type these things in, and we're going to see how to do it that way. Because there's kind of a couple cool features. Now, I had been doing some work earlier on this. So we'll just go ahead and retype. I'm going to say, and you don't see me right now, but that's probably okay. Negative 4x plus 8. And for the other one, ooh, wait a minute. I still have 84. That's not going to work so well, is it? That's going to be crazy on my...
Tim Brannicky, your ride is here. Tim Brannicky, please come for your ride.
And then my other equation that we solved for is just 2/3 x. So we're going to type that in. 2 divided by 3 x, and then we're going to minus 6. Okay? Now, when you go to graph, you're going to see the two lines, okay? And maybe, especially if you have the new calculator, you could go, well, that's 3, and that looks like negative 4. But there's an even better way to do it. If you press second calc, which is right above trace, okay, so I press second, and then this trace button, it says calc, you can go down to intersect, and they ask you, what's the first curve you're looking at? This one, and in our cases, there's all lines. What's the second curve? Oh yeah, it's this one. And here, just in case you don't have enough fun, it even lets you put in a guess. I'm not going to bother. I'm just going to press enter. And look, it tells me 3, -4. So there's a lot of different ways to do this just with graphing. Okay? You can use your calculator. You can do slope-intercept form. You can do the y and x-intercept, whichever way. Okay, so now that you've seen that, let's do maybe a couple more examples. And so we'll pull up this other one and run it, at least for a while. Okay? Now, same thing, it tells you to solve the system, and we have to figure out if it's consistent and independent, or inconsistent. Well, if you remember, those 3 were about the graphs, so we're going to do the same thing. We're going to graph it. So right now...
James Myers, your ride is outside. James Myers, please meet your ride.
So right now, we're going to actually do some of the work for this. So let's go ahead and turn on the lights, and then we'll practice these 2 equations. I'll get them down. There we go. So 4x minus 3y equals 8. And then we have 8x minus 6y equals 16. So we need to graph these. So we got to get y by itself. So in the first one, we're going to say, what do we get rid of first? The 4x. So we subtract that. What are we left with? -3y. Can we combine these? No. One has an x, one does not. What's the next thing we need to do? Oh yes, divide by -3. You get y. What is negative divided by negative? Oh yes, it's positive. You get 4/3 x. What's positive divided by negative? Negative 8/3. Kind of some ugly numbers, but we can handle it. Let's go ahead and do the next one, and I'm going to do it right underneath. You've got 8x minus 6y equals 16. We're going to subtract 8x from each side. We're left with -8x plus 16. Divide by -6. What is negative divided by negative? Oh yeah, it's positive, and we've got 8/6x. And what's a positive divided by a negative? Oh yes, a negative. You've got 16/6. Now at this point, some of you might be going, wait, can't we reduce 8/6? They're both even. So if you take 2 out of both of them, you're left with 4/3. And here they're both even, so you're left with 8/3. Okay, they're exactly the same. Well, let's check out this on the board and see what happens. Okay, so we'll go ahead and turn off the lights, and then we'll look and see what happens. The graphs of the equations are the same line, just like you thought. Now notice it intersects at -8/3, so let's see, that's almost -3, so right here. And then we go up 4, so 1, let's see, are these, yes, these are just in, so you go up about 1 1/3 and go over 1. So it's right here. It's exactly the same line, so if you look on your study card or back in your notes, it's consistent and dependent. Okay? We're real quick going to look at one. Now this one you might notice that the y's are exactly the same and the x's. If you solve, you're going to get parallel lines. So we'd say inconsistent, just like our paper shows us. We're not going to worry about this one. And we're not going to worry about this one. But here's one nope, this is the one I want you to see. So this one's going to be -x plus 2. This one's going to be positive 2x plus 5. Well, I don't think they're going to be the same line. And they aren't. They would cross at -1 and 3, which you would get after graphing, consistent and independent. We'll practice in class, and I'll see you later. Bye.